everyone. Super happy to be here on this new Let's Talk AI episode. Today I'm with Panos Alexopoulos. Panos, how are you doing?
Hi, Thomas. I'm
I'm
very
super
well, thank you.
very happy to hear that. I'm super happy to have you today on the show and I have very specific topics that I want to discuss. First of all, for the people who might not know you, so you're a data and semantic practitioner. You're the author of the book Semantic Modeling for Data. And it is a book published by O'Reilly, and you're currently head of ontology at Textkernel. So that's a very brief description, but maybe you can enhance my description with your own words.
Indeed. So again, thank you very much for inviting me to this podcast and giving me the chance to address into a large, hopefully, audience with respect to AI. Yeah. So the three things you said are quite correct. Generally, I've been working in the field of ontologies, of knowledge representation and knowledge engineering since around 2005. So
Mm.
I'm let's say from a previous era where machine learning and big data and data-driven approaches were not that successful yet.
Yeah.
Mainly because we didn't have, of course, the computing power back then, and also the data needed in order to do these approaches. So I mostly followed the path of what we call now symbolic AI,
Mm.
which is about describing world knowledge and world data into a declarative way and telling machines what to do rather than try to to teach them what to do. Um, so for the last 15 years, I've been working a lot in conjunction with, in close collaboration with academia. I have
Hmm.
participated in many projects that involved industry academia collaboration. I've done research, published some papers, also I did a PhD. And for the last 7 years, in 2016, I joined Textkernel. Textkernel is
Hmm.
a company that builds software for recruiters.
Okay.
What we try to do is match people's profiles with jobs, job vacancies. And we try to do that in an intelligent way by utilizing AI techniques, among which is also semantic modeling and knowledge graphs that we're going to talk about today.
Wow. That's very interesting. Um, so, speaking about semantic modeling, knowledge graph, you're the author of an O'Reilly published O'Reilly book. What inspired you? So the full name to the people who are listening is Semantic Modeling for Data: Avoiding Pitfalls and Breaking Dilemmas. Uh, why did you start writing this book?
I think that the answer to that is in the subtitle of the book, Avoiding Pitfalls and Breaking Dilemmas. So the story starts more or less as follows. When I joined Textkernel, the main mission that was given by my hiring manager was, and by the company, was to start building a knowledge graph about skills, professions, and other concepts related to the recruitment domain, the HR
Hmm.
domain. And having already done, as I said, some research and worked in the field for more than 10 years, I felt quite confident in that, okay, I could pull that through based on the knowledge of semantic technologies and knowledge presentation that I had already, along with the latest developments back then to NLP and machine learning, and of course the availability of a large amount of data that would help um, do build a knowledge graph in a scalable and efficient way.
Hmm.
As you can imagine, things didn't go as as always as expected.
Hmm.
And in these 7 years, I've learned several uh, things from either not complete but partial failures that we had, and things that didn't work exactly as expected. And that was the main inspiration for me to write this book. And it's important to how to say, I want to highlight what do I mean by pitfalls and dilemmas right here. So pitfalls are things that are practices and things that we do when we develop knowledge graphs that will most likely, in 90% of the cases, lead to some problem, right? Leads
Mm.
some suboptimal result, something that will not be accepted by the users and or the applications that we build the knowledge graph for. And the thing is that many of these pitfalls were often written in either books or tutorials or academic papers as good practices. So one reason I wanted to write this book was to highlight the fact that this piece of advice were not not as good, were not as let's say safe as one thought they would be. And this is not an accusation on those who wrote them, right? Because these things are you realize and you find these pitfalls only when you do a lot of practice and in different contexts. So it can be that in some cases this advice worked, but in some other cases it didn't work. So
Mm-hmm.
the challenge is about generalizability of advice. The second thing is dilemmas. So something that I also realized was that almost every day when I want to work and I planned, okay, what to do next, I kept coming across questions that I wasn't really able to answer because
Mm-hmm.
there were not so much answers about how to do things, but what is best to do in a given situation. And often I didn't really have the the knowledge that I needed in order to take this decision.
Mm.
So I had to look for that. Because also for this, and I call them dilemmas because there was not a correct answer. There's never a correct answer to that. So, for example, if you build a knowledge graph and you decide to focus more on the precision, on the accuracy of the
Mm-hmm.
knowledge rather than the coverage, it's a respectable choice, right? Because usually there's a trade-off between these two. Um, but to what extent you should follow that approach, it's something that the market will tell you, the business will tell you, the product manager will tell you, the user will tell you. So you
Mm-hmm.
really need to have a way to tackle these dilemmas. So what I tried in this book, apart from the pitfalls, was to give some guidance to practitioners of knowledge graph and semantic models on how to seek the information they need in order to resolve these dilemmas, in order to break them.
Mm-hmm.
So I would say these were the main two inspirations for my book.
Hmm. Very interesting. Um, all right. So I think my next question and what I would like to ask you about is um, maybe kind of related to the first one, but um, all right. So right now we've heard a lot about NLP, and more than ever when we can hear about large language models. So there are in artificial intelligence, sorry, and in machine learning, there are so many fields and subfields. For example, LLMs are just a subcategory of deep learning, and so what are the benefits? I guess my question is, what are the benefits of focusing on data modeling and knowledge graphs? And maybe if you can share like some real world experience.
Yes, that's a great question, and it's a question that I very often receive. I think we need to go a bit back on the fundamentals, right? When we were taught in university about AI in general and about machine learning. So if we think about it, machine learning is an approach that tries to create computer systems, right? Programs that
Hmm.
improve automatically through experience, right?
Yeah.
So these are programs, right? This is an approach where you assume you know nothing. You get data, you get input from sensors, from whatever, and you try to automatically understand the world. Symbolic AI, on the other hand, and knowledge presentation, tries to explicitly represent what we have in our heads as humans in a declarative form. So we try to declare facts and rules about how the world operates, right? So when we
Hmm.
say that I don't know, Panos is a human, right? That's a fact. And when we say that all humans are mortal, that's also a fact that can be used to infer also that Panos is mortal, right? And Symbolic AI started like that. Obviously, as we see now, it was never enough in order to really build intelligence systems. And the main reason was that it doesn't scale, right?
Mm.
On the
Mhm.
one hand, doesn't scale, and also many aspects of what we have in our heads, we don't even know how to express them. So
Mm.
what LLMs and what machine learning tries to do is find patterns that we may not completely understand. That's why
Mhm.
we also have this big black box problem with recent AI, but nevertheless seem, I say, to understand us. I'm not saying it's understanding. I'm not, but they give us the illusion that these systems learn and understand. So in practice, machine learning is about induction. It's about a way of thinking that starts with an observation and then trying to understand from the observations, trying to get to a theory. Whereas symbolic AI, knowledge presentation, and of course knowledge graphs is about deduction. It's
Mhm.
about starting from a theory that we know it's true, or at least we're very confident that it's true, and then by observing the world, we can make deductions and inferences. And in the question is which one is better, I think it's the wrong question, right? So machine learning has scale, right? You can, if you have enough data and enough computing power, you can compute many things. But it also has noise, right? It also has noise and it has little transparency. It's very hard to understand what's going on underneath. On the other hand, symbolic AI is much slower, but it's more transparent and allows also human influence in the machine. So, for instance, if you have a knowledge graph and one of your users say, this fact is wrong, you can easily go and fix it. If the same fact is generated by a machine learning model, you might not be able to fix it immediately because first you have to understand why it has been generated. It's not so explicit.
Mhm.
So for now, at least, I don't know what will happen in 10 years. We need these two approaches to work together, right? We shouldn't treat them as opponents. We should treat them as collaborators. We build knowledge graphs in order to facilitate better machine learning, and we also use machine learning to build better knowledge graphs,
Mm.
right? And this is what I think many organizations currently do, including Textkernel.
Hmm. Super interesting. Would you have an example of a knowledge graph, like real world example, and maybe how machine learning can enhance this knowledge graph?
Okay, right. So again, I will start with generally, and I will give some examples. So the primary function of a knowledge graph is to connect and contextualize data in a way that makes the meaning of this data more explicit and shareable.
Uh-huh.
Given this, one common application in many companies, many organizations of knowledge graph is to use them as a way to semantically integrate heterogeneous data,
Yeah.
and then run data science or data analytics on top of this data.
Mm-hmm.
And why is that better than, and why do they do that? Why do we do that? Because by connecting data, we give them, we improve their quality, and we give them more meaning, and we're able to have better accuracy. A very simple example from the recruitment domain. Let's say that we want to count how many truck driver jobs have been created in the last 6 months in the US,
All right.
right? In order to do that, we we need to count how many job vacancies have been published about truck drivers.
Mm-hmm.
The thing is that the titles in the job vacancy may call a truck driver in many different ways. They may call them truck driver, If they're from the UK, they may call them a lorry driver. There is a lot of there is a lot of variety in which the same thing can be said.
Mm-hmm.
Vice versa, not necessarily about truck driver, but vice versa, you can have ambiguity. You can have things that have the same manifestation in language and in text and in the data, but ultimately mean something very different, right? So that means that if you are just based on keywords, if you're just based on raw data without having them integrated in a semantic way and without practically analyzing entities and rather than strings. I think this was the Google's slogan back in 2012 when they introduced their knowledge graph, and they were saying, things, not strings, right?
Mm.
So
Yes.
knowledge graphs and semantic modeling allows us to operate on the entity level, on the concept level, rather than on the string and term level, and that
Okay.
already gives an advantage in analytic applications, in data analytic applications. And
Okay.
this is something that currently many organizations do, but two domains where this is quite how to say, it's quite common nowadays is healthcare and pharmaceutical domain. We have large pharmaceutical domains that use this approach in order to do drug discovery and various other applications on top of biomedical data. And also another domain is finance, financial service, financial organizations like Bloomberg, for example,
Mm-hmm.
who again put data together, and then they are able to do things like fraud detection, to understand critical events, to try to do prediction, to try to see the volatility of the market, things like that. And I already gave you an example about the recruitment domain, like for example, understanding the labor market, etc. So
Mm-hmm.
you can take practically any domain where you do analytics and you do data science and you want to do that better. By doing semantic modeling, you are improving the input to your data science applications. You are improving a lot, how to say, the starting point of what
Yeah.
you do,
Uh-huh.
right? It's also the famous, again, I don't know if it's famous, I think it's famous slogan, garbage in, garbage out. You want to avoid that. And by
Yes.
doing semantic modeling is one way to avoid that.
Okay. Very interesting. And I would assume that now with LLMs, it is combining not strings but entities with these large language models. There are a lot of things to play around with.
What do you mean? Can
I
you
mean,
elaborate on that?
yeah. I mean, so if I understand correctly, you have this graph. You have, like, you're able to create these entities, like not strings. You're able to create
Yes.
entities. Let's say the labor labels, like you mentioned. Um, how could that mix with NLP and with maybe training large language models or other NLP techniques? Um, I think what I'm trying to ask is, like, how does graph models relate to NLP, and if like yeah, if like it can be very useful for LLMs.
Right. I don't have much expertise on that yet, at least on. But what happens is that many applications related to NLP are about entities, right? So
Yeah.
let's take the very basic. Let's take an LLM. And let's say that you ask now LLM, give me the biography of Thomas Bustos, right?
Okay.
Um, how the LLM will try to give you an answer, but does it really know how many Thomas Bustos are out there? How it can discriminate between them, right? And yeah, if there are more than one, how can we tell it which one to choose, right? How do we give it context?
Right.
Some couple of months ago, I posted that on LinkedIn as well. I asked GPT-3 back then, I think. Okay, um, give me give me a bio for Panos Alexopoulos. And it wrote me a bio where it made me CEO of the company I work for and invented many other things that were not really true,
Hmm.
right? So the thing is with LLMs that they don't have grounding in real world knowledge. It's right.
Hmm.
It's they get what is in the data. So we really have to be careful with LLMs when we ask them about factual knowledge, right? That also may change as time passes by, right?
Hmm.
Because
Hmm.
let's say that if an LLM that is trained on data learns some facts about the world and then for example the professions of some people and then these people change profession the next day or change
Hmm.
the company, how will the system ever learn about this,
Hmm.
right?
All right. All right. I see.
Yeah. But at the same time, it's many things that used to be done almost exclusively by symbolic AI and knowledge graphs can now be done much easier with an LLM. So, for instance, if you want to do question answering on top of a knowledge graph,
Yes.
question answering was notoriously difficult in the sense that you had to take a natural language question, transform it into a structured query, and then run it against the knowledge graph. The
Right.
translation part from the natural language question to the query was and is one very difficult things because you don't have a lot of context. And
Yeah.
this, I think, is where LLM is one of the applications where they can be very useful.
Huh. That's very interesting. I think when I think about model graphs, I'm thinking about Wikipedia, uh,
Sure.
and uh, and like how they maintain information and try to be as neutral as possible and as accurate through time as possible. I feel like it have some similar values to what we can do when we're talking about model graphs. Could that be a correct um, association, kind of, or would you say not really?
Can you? Sorry, I didn't exactly understand the question.
I was saying when I'm thinking about Wikipedia,
Yeah.
um, I feel like Wikipedia can really be a great way of a model graph. Could you compare Wikipedia and making a graph model from Wikipedia?
There is a graph model of Wikipedia. It's called DBpedia,
Hmm.
actually.
Huh.
Well, in practice, DBpedia is a subset of Wikipedia in the sense that it's a knowledge graph that is built by extracting information in an automatic way from Wikipedia info boxes. So they
Okay.
don't analyze the whole article,
Okay.
but they get information from info boxes, which are semi-structured, and they populate that information using also
Hmm.
an ontology. Yeah, and it has pros and cons to what they do, and its quality is also depending on what you look. So, for instance, the Wikipedia has a big problem with respect to abstract entities. By abstract entities, I mean entities that do not have a concrete manifestation, right? So,
Okay.
people, locations, buildings are concrete entities. um, how to say, fields of study, scientific facts, these things are abstract entities.
Hmm.
So, for instance, if you go to DBpedia right now and you say, okay, can you tell me in which class does machine learning belong? I don't know now, but I have an example of that in my book. At least a couple of years ago, it was a disease.
Okay.
So it didn't have a way to classify machine learning to say what type it is, for
Okay.
instance. Whereas, for example, it could identify that I don't know, Roger Moore is an actor or a
Hmm.
or a person. Yeah.
Hmm. I see. Um, All right, you mentioned challenges, like the pros and cons, the challenges and opportunities. May I ask you about the specific challenges and opportunities about when building a knowledge graph?
When building a knowledge graph. Yeah. Um, I think I mentioned that the main challenge is scale, right?
Okay.
You know, when we started, when I started ontology modeling around 20 years ago, the typical examples we would see would be small ontologies. You know, we would open one editor, define, I don't know, 10, 20 classes, 10, 20 concepts, some couple of relations, and that was it.
Okay.
When we go from a few concepts to thousands or millions of concepts and interrelations, um, keeping quality steady, if not getting improved, is a challenge. And scaling can be in two ways. One is in two dimensions. One is to increase the size and
Hmm.
coverage of domains. So, for example, you have a knowledge graph about, I don't know, sports, and then you want to expand it also with politics and with, I don't know, fashion and art. That's one thing. And the other is the perspectives and viewpoints and the context where you use it. So you
Okay.
might be building a knowledge graph to be used only in a small community for one application only, or for the whole world.
Okay.
That's very challenging because the difficulty in scaling semantics, in scaling a knowledge graph, is ensuring that a fact that in a given scope is correct, is considered as accurate, is also accepted as accurate in the broader scope,
Hmm.
right? So we see that a lot in the HR and recruitment domain with skills and occupations. For instance, we have occupations, professions, right, in a country that when we translate it in another language and to be used in another country, this profession does not exist, or it has a different composition, a different interpretation,
Hmm.
which means that these are not equivalent anymore. We believe they're equivalent because we translate them based on the common language, but really, in terms of content, they're not really the same.
Hmm.
Or when you try to, for example, again, model a profession, let's say data scientist,
Hmm.
and you try to think, okay, what are the skills of a data scientist? If you start by modeling this, I don't know, in the financial domain, there are skills that perhaps in the biomedical domain are not necessarily equally essential, equally important. Of course, there
Right.
are some core things, but there are changes across domains and across context that you may have not thought about.
Hmm.
So as you try to scale this, you are always constantly trying to see if you are really if your quality remains the same.
Okay.
So that's I think that's the main challenge, and in conjunction with the fact, in combination with the fact that the real world is messy, right?
Yeah.
There is ambiguity, there is set variety, there is vagueness, there is uncertainty. All that mix makes it quite challenging.
Hmm. I see. And I will make a very basic questions, but I haven't been the opportunity to work much with knowledge graphs, so I would really like to ask you about some pitfalls, some dilemmas, and you mentioned some of them right now. But maybe can you briefly explain to me and to the audience, like a typical approach of building a knowledge graph? Like, what are kind of the main steps that you would go for when building a knowledge graph?
Yeah, sure. So it's the main steps are not so much different than any software engineering also problem, in a sense, right? You
Uh-huh.
start
Yeah.
with what you want to build, some kind of specification, right? What kind of knowledge, what kind of data you want to connect, if you're connecting data, what kind of knowledge you want to model. And then it's important to follow up with, as I like to call it, to give a shape to the graph, right?
Okay.
to practically build a schema. There are technologies out there, there are approaches that say, just put the data and connect them, but really a schema is important. You can call
Mm.
it an ontology, I call it a schema in general. It's practically a knowledge structure that in a semantic model on itself, the schema that tells us what the knowledge graph will contain,
Yeah.
right? It
Mm.
might just contain a couple of classes, some relations, but we want to understand what entities are we going to have and how are they going to be connected.
Right.
And this can already be a challenge because we really need to think through what to define these models in a rigorous way and in a commonly accepted way. After we have the shape, we need to give it substance. We need to populate it. We need to give it data, right?
Yeah.
Which means that we need to identify the resources from which we're going to populate it. These sources can be people,
Okay.
domain experts, right? Which of course I said don't scale, but they can also be other knowledge graphs, other databases, semi-structured data, and text many times, right? So just pure text, articles. And the way we do the population, there are several techniques there, right? There are techniques from machine learning, from NLP, like entity extraction, entity linking, entity relationship extraction, with different levels of maturity and of
Mm-hmm.
um, different levels of maturity and effectiveness, right?
Okay.
For example, in general, given the state of the art, the relation extraction task is more difficult than the entity extraction task. It's easier to find entities than to find particular relations like synonyms, for example.
Right.
Then, when we do the population, we need a way to know that it's good. So we need to have a quality framework to
Mm-hmm.
identify what dimensions are important and how to and measure them in a way, right? So if you tell me you have a knowledge graph, I will ask you, okay, can you tell me what is the accuracy of the graph? What is the completeness? What is the understandability by the users? There are several dimensions that we don't have enough time to cover all of them here. And then another stage, which again is very important, and it can be a pitfall if you don't do it, is to make it useful, right? To put it in people's hands
Right.
or in applications' hand to do something with that, because usually on its own it doesn't provide much value, right?
Right.
The application can be things, as I said, like question answer. It can be semantic search. It can be recommendation systems. It can be as part of a bigger machine learning system that does something. It can be
Mm-hmm.
anything, right?
Yeah.
And the final step is to make it last.
Okay.
You build it. You build the first version.
Right.
Depending on the domain and the kind of knowledge it has, it may be quickly obsolete. So you need to make sure that it keeps being relevant and keeps having content.
Mm-hmm.
Now, with respect to this life cycle at a high level, there are several pitfalls. One big pitfall at a very high level is not having a strategy on how to build it, right? And by strategy, I mean what and why. What you want to build, right? I mean, if you just tell me, I just want a knowledge graph because it's cool, or I just want a knowledge graph about, I don't know, biology, this doesn't say a lot. It's a bad strategy. But if you say, I want to build a knowledge graph about this particular domain in order to power this particular application, for example, a recommendation system or a search engine,
Mm-hmm.
that's already a good start.
Mm.
Strategy is also about dilemmas and choices that I mentioned earlier, right? So it should be part of a strategy what kind of, for example, quality criteria you want it to have. Do you want to compete with your knowledge graph in terms of accuracy? You want to build it, to focus more on getting a lot of coverage and a lot of completeness rather than accuracy, because these choices will affect a lot how you're going to develop it. If
Right.
you want high accuracy, you most likely need people in the loop, humans in the loop, which means also human cost, right? Cost in terms of that will affect the cost. If you don't care so much about that, you can probably utilize very easily existing machine learning systems and NLP and quickly give you something, right?
Mm.
But and that's why you see I see sometimes articles that say, build a knowledge graph in a week or so. Yeah, of course. What I like to say is that you can build a knowledge graph very fast and very easy, but it's not necessarily the knowledge graph that you need, that you want.
Hmm.
And another pitfall that comes to mind, again, giving the steps, is building it very times just to build it without considering the application in mind. Right? I'm not saying that you should always tie it to an application, and always do what the application wants, because sometimes the application will make you uh, will make you take shortcuts um, that reduce the semantic interoperability and generality of your knowledge graph, but still you have to take it into consideration.
Right. All right. I see. Well, when we speak about semantic modeling, um, I have vector database that comes in mind. Um, and I was wondering if knowledge graphs could be combined with vector database. Could you maybe give me some perspective on this?
Um, okay, I'm not very how to say knowledgeable about vector database in particular, but if I understand correctly, you are talking about embeddings in general, right?
Yeah, I mean, like the idea of having vectors in databases and being able to yeah, exactly, use, for example, embeddings. And I would assume that knowledge graphs can be enhanced by embeddings, but maybe, let's say, yeah, can like knowledge graph, can you tell me more about this?
Right. So if we think of embeddings, right? When the first embedding model started with Word2Vec, what we were doing was mapping terms and words, right, into vectors,
Right.
vectors of embeddings. In general, such a representation operates at the sub-symbolic level, right? Because these are just numbers. If I show you a vector, you have no idea what that is, correct?
Mm-hmm.
Knowledge graphs and semantic models operate in the symbolic level, right? That means that any relation between two words should be explicit, should just have a name. So Panos works at Textkernel. That's a symbolic representation. Now, if
Right.
you have the embedding of Panos, assuming that you also have the identity of Panos Alexopoulos, and you have the embedding of text kernel, and maybe you can take the joint embedding of both in a way, what you still miss is the relation between the two. Maybe you can infer it by also taking the embedding of the works at relation. So yeah, it's not the same, right? Definitely, embeddings can be used as a way to not to infer, to mine knowledge. So, for instance, if you want to build a synonym classifier to tell you if two entities are the same, it's very likely that by taking the two terms that you want to find if they are synonyms and take their embeddings and compare them, hopefully they will have a high similarity, and that might give you an indication that they are synonyms. But it's not certain. It's not
All right.
guaranteed, right? So it's two different things.
Okay. Okay. Thank you for your answer. Um, you mentioned something very interesting before. You mentioned use cases about semantic modeling. And let's say I'm in my company and I want to go to management because I have a great application of a semantic model. Maybe I have a proof of concept, and I have a great application like you explained well. Like I have this because I want to do that, and so I will work on this semantic modeling for these specific goals. How do you convince management to invest in semantic modeling?
Yes, that's a great question as well, because I get it a lot from people that try to do semantic initiatives within their organizations. So yeah, this comes a bit to the beginning that we were discussing about what is the benefit of a knowledge graph. So the thing is that the benefit of semantic models, so ontologies, taxonomies, right, a knowledge graph, is not immediate. It's not something that it's plug and play. You see it. It's not as fancy as an LLM that immediately you see that's very interesting what it does. In order to to get support, right? As in many things in business and organizations, right? You need to identify a pain point first, right? Something that you see that it's that something that the way it's currently done, of course, data related, right, is not optimal, and creates problems, creates inefficiencies, and is something that your manager can understand and can feel the pain,
Mm-hmm.
right? Starting with that, right? So, for instance, you might have a dashboard, an analytics dashboard that you realize that nobody uses, and when you ask your users why you don't use a dashboard, they say because the output is not correct, right? We see many semantic errors here.
Mm-hmm.
That's already something that can give you an idea of what to operate. So the first thing is to pick a use case that is a known pain point, and as if possible to be an important pain point, so as to take priority. The second thing is to make sure that the pain is caused by problematic data semantics, right? So it shouldn't be just a bug in the code or some engineering, something that it's a matter just of engineering. And usually semantic problems have to do with heterogeneous data that have been merged together when they shouldn't, with things that have their own identity, and that when you analyze them, they give you totally wrong, very wrong insights. So insights that really are not there, predictions that do not prove, that do not become true in the end, things like that.
Hmm.
When you identify that, then you think that this pain point can be addressed by creating a small knowledge graph, an ontology, etc. You need to pick a metric that you can improve by applying a semantic model, right? Because you need to show cause and effect, right? You need to start say, okay, this is the situation now. We can make a small pilot where I built, I don't know, a small ontology. We apply it in this way, and look, we already have an improvement with that aspect that we care about.
Hmm.
And when doing that, it's also very important to focus on the data semantics, not the technology around them. Because I get the question, okay, should I use RDF? Should I use OWL? Should I use, what kind of technology should I use? And usually when you try to, in a POC, to introduce a very new framework to engineers and to product managers, especially if it's costly, they will react. They will say, no, why? So the focus, I think, there the focus should be on the data. You can use very easily whatever your organization uses already. Is it a relational database? That's fine. For the POC, it's enough, because what you are what you are evangelizing, what you are advocating when you come to semantic technology, it's more than the technology itself. It's more the mentality of thinking beyond a single database, but rather thinking with respect to connecting data,
Mm-hmm.
right? And you can connect data again at the POC level very easily with just simple formats that all engineers know. JSON, XML, even things like that. You don't have to necessarily go and do some and train all your team in RDF and OWL, for instance, or Neo4j or things like that.
Hmm.
And finally, it's don't build something too complex, right? Again, you need a POC, right? If you start, because the cost can really, increase. Yeah, you need to show a value as a promise of value as soon as possible.
All right. All right. And when you approach, so I assume that I mean there is a big academical part, like about semantic modeling, building knowledge graphs. How do you bridge the gap between academy and industry when, for example, you're doing speakings or you're doing training engagements? How do you break how do you break this barrier?
That's a hard one. Yeah. Okay. Yeah. As I said in the beginning, yeah, I've started. I have worked a lot with academia as part of my PhD, but I was always in the fringe between academia and industry. And it all starts with realizing that there are different goals. There are different priorities and metrics by which success is measured, right? Academia, of course, does state of the art research, does frontline research, right? They need to find new ways to do things. They need also almost always, so state of the art, in a comparative way.
Hmm.
And at the same time, they lack actual users, and scenarios. When I was also doing my PhD, most of my scenarios were not fiction, but rather, trying to think how it would look, or doing, experiments with a few people, with 5 people that were also quite biased because they were either other ontology modelers or users.
Mm.
Um, um, on the other hand, industry practitioners may not be always up to date with what are the latest developments in academia and academic papers. Also, the language that an academic paper uses, or the I don't know, the representations, the formulas that they use may not be as accessible, and that makes it difficult. So what I do is practically is the following: when I write a book like the one I wrote, or when I prepare a course for practitioners, right? I'm trying to translate the language of academia where possible into concepts that are more common in an industry jargon, right? Trying as much as possible not to simplify too much, right?
Mm.
And that's the main thing I do currently. I have For the last years I have stopped doing so much academic publications. My writings are more about the practitioner side,
Hmm.
but I try to transfer as many concepts as possible from academia. Vice versa, when I'm in an academic setting, what I'm trying to do is communicate the challenges that we face as industry in order
Hmm.
to somehow, how to say, try to steer, the focus on of research also in topics that may not seem as interesting now in an academic setting, but that we're still struggling in the real world, right? So
Mm.
I've seen many times topics that for which papers were written like 15 years ago. Nobody writes papers on these topics anymore, but they are nowhere to be solved yet, right? When you try
Hmm.
to apply them in an industry setting, like for example ontology mapping, or even relation extraction, these are not solved problems yet, right?
Mm.
And of course, industry academia for funding purposes also has to adapt in, what is what is currently funded and not. So yeah, it's not an easy task. I don't succeed always, many failures, but yeah, it's something that I
Mm.
like doing.
Well, that's a very interesting field. A field that um, I don't have much visibilities as if I were to discuss data engineering or data architecture, but nevertheless, I would say it's a fascinating, and I asked you some specific questions, maybe some wrong questions, but I feel like this is
No,
all
there are no
about
wrong questions. There are never wrong questions.
exactly, and by doing these questions, I have the intention to maybe say something that's wrong so that I can learn the truth. Uh, and uh, and you've done a great job sharing and explaining me. I think I would have maybe regarding the industry, out of curiosity, how do you see knowledge graph, semantic modeling growing through the upcoming years?
Whew, that's a good question. I'm not. I don't know if it's going to grow. So I was actually like I was looking at Gartner's. I don't know if you are aware of the hype cycle, and currently knowledge graphs are put, I think, under the trough of disillusionment and go towards plateau of productivity. Um, from my experience, because I said I've been working on in this area for almost 20 years now.
Right.
Um, there is, how to say, the underlying principles and the underlying need for making data and meaning clear, it will always be there. Now, the way we express these and technologies might change, then there is always a rebranding of things.
Mm-hmm.
So, knowledge graphs now, everybody talks about knowledge graphs, but they are not really that different than what were semantic networks back in the 80s and 90s or linked data. There are differences with respect to technologies, with respect to capabilities of how they can be used, but they're not really that different, right? And I think to the extent that the purely machine learning approaches, the LLMs and the other approaches do not manage yet to provide not necessarily intelligence, which is we go back to AI, but in practical considerations, if they're not able to do yet to provide safe, transparent, and yeah, and explainable to some extent
Yeah.
applications, data modeling will be needed. And also remember that all this AI that we have now, like let's say the LLMs, are really data hungry. And doing semantic modeling is a way to not to ensure, but to work on the quality of this data. Because if you start, if you cannot just trust the AI, at least yet, to have its own, how to say, to control the quality of its own data that it
Right.
uses, right? It's a vicious circle. So you have to make it a virtuous cycle, and that's tough.
Right. Right. Maybe it will play a huge role regarding data observability when we arrive to a point where companies are very well powered by data, and therefore being able to like do more advanced data analytics will need to have this knowledge graph, for example, or semantic models underneath each department of the company. Maybe. How does this sound?
Yeah, sure. I like to consider and to define. So there is a difference between. So we talk about LLMs, for example, and yeah, and LLMs and machine learning in general versus knowledge graphs. So a knowledge graph is an artifact. First of all, it's not really a system. That's one thing,
Mm-hmm.
and it's a means of communication. It's something that we build in order to communicate, two applications to communicate to each other, right? An organization to communicate to bridge the semantic gap.
Mm.
So the knowledge graph itself is not an application. This is
Right.
really important. So
Okay.
you have to
Yeah.
consider it as a component that, again, for the short term, for the immediate future, I think is important, whatever forms it might take. Right? Maybe we start calling it knowledge graph. Maybe we start making something hybrid. So, for example, having the knowledge graph as it is now with combination, with vector database, as you mentioned, with embedding. So, adding some symbolic stuff,
Mm-hmm.
adding some probabilities, adding some. Actually, there were probabilistic knowledge graphs back then for a while. So, yeah,
Okay.
I would say that. I mean, I'm not much of a philosopher, but in all these years that I have been working, I really haven't seen a massive paradigm shift in what's happening still in the in the data world. We have a lot of data. Yes, we have better tools, but the struggles are the same.
Right. Interesting. Um, I will for sure do more research on all these topics that we discussed, and it have really um, improved my interest for knowledge graphs, for semantic modeling. I have two last questions, but before those two questions, I want to thank you, Panos, for your time, for coming on the show, for sharing your expertise,
It was
and
my pleasure.
what you're doing. It is very very interesting. My two last questions are, first of all, for the people who are listening, where can they learn more about you? Where can they learn more about you and what you're doing?
The best way is to find me through LinkedIn if they have one, right? Also, there is my website, panosalexopoulos.com, where they can find also, you can download a sample of my book as well and find more information. And there's also a contact form. So, apart from that, I generally try to give talks and trainings also through O'Reilly platform, who's my publisher for the book, but also some industry conferences. And usually I use LinkedIn as the main channel where I make these announcements.
Awesome. Last question. Would you have a message for the Let's Talk AI community? It can be something that you shared in the episode, a specific, for example, knowledge graphs are artifacts. They are not systems. This is something that
No,
I
yeah,
learned.
no,
Would
I
you have
don't
a
have.
message?
Yeah, I have a message. I mean, message. I think it's not so much about knowledge graph per se, right? Because knowledge graph is just a small part of the whole AI thing, and I think also given the developments with the large language models and the whole AI, the whole discussion about AI and whether it's conscious and whether it's safe and whether there is a risk, I think the message is. All of us that work in developing AI systems and put AI votes in the sense that practical AI, right?
Mm-hmm.
Let's make sure that what we build is safe, right?
Mm.
Is useful and safe.
Awesome. Thanks a lot, Panos, and I wish you to have a wonderful day.
Thank you, Thomas.